Thanks for taking the time to watch this video. Just a note that if you're interested in any one-on-one tutoring, I do offer that service. If you're studying calculus, physics, or chemistry, I could certainly help you with that, and you're welcome to contact me at this email address to arrange a private tutoring session through Google Meet or through Zoom. You might want to pause the video and reread the problem here, but in this problem we have a compound known as washing soda, and they give us this formula for washing soda right here. Now, if you look at that formula very carefully, you will notice that there is an implied 1 in front of this sodium carbonate portion of the formula, and then there is a coefficient of x in front of the water. And these two numbers, the 1 and the x, are in moles. It's very important to understand that the 1 represents the number of moles of sodium carbonate, and the x represents the number of moles of water. So we have to figure out x by considering the moles. Now, we read the problem and we start out with 2.558 grams of washing soda. So let's try to represent that in a very simplified manner. So that would be an illustration of the compound. The black portion represents the sodium carbonate, and then it's sort of surrounded by the blue portion, which is the water molecules. And again, the mass of this compound that we begin with is 2.558 grams. But then this compound is heated, and it says that all of the water of hydration is lost. So you can imagine taking this compound, heating it. We use the little delta symbol to represent the heat, and that heat drives all of the water molecules off of the compound. So now the water molecules would be sort of separated from the sodium carbonate. So it might look something like this. And the question notes that the mass of sodium carbonate at the end of this heating process is 0.948 grams. But for the water, we can simply figure that out because of the conservation of mass. Let's call the amount of water in grams y, and the conservation of mass tells us that the mass that we started out with, which is 2.558 grams, must equal the mass that we finish with. So that would be y plus the 0.948 grams. Now, of course, we can easily solve for y by subtracting from both sides the 0.948. And when we do that, we get 1.61 grams of water. That's going to be the number of grams of water that was present after the heating, but also it's the number of grams present before the heating as well. So if you think about this very carefully, then you now realize that the original compound contained 0.948 grams of the sodium carbonate, as well as 1.61 grams of water. Now that's good, but we mentioned earlier that the numbers or coefficients in the formula represent moles rather than grams. So we're going to need to convert these masses into moles. So we'll start out with sodium carbonate. And you probably have learned how to do these mole conversions, in this case grams to moles. And what we do is we make sure that the dimension that we're beginning our calculation with is placed in the denominator of our conversion factor. So if we start with grams of sodium carbonate, we have to put grams of sodium carbonate in the denominator, and that way it's going to eventually cancel out. Now we convert grams into moles, so we can put in the numerator the moles of sodium carbonate. So now what we have to do is figure out what mass is present in 1 mole of sodium carbonate. And to do that, we're going to have to look at a periodic table. Here is our periodic table. We look at the formula and we see that there are 2 sodium atoms in the formula. We've highlighted the sodium as well as the mass, which is 23. So you would take 2 sodiums and multiply that by 23. In the formula, there is only 1 carbon, and the mass of carbon you can see is 12. And then we have 3 oxygens, each of which has a mass of 16. So if you compute that value, you will get 106. So what does that mean? Well, it means that 1 mole of sodium carbonate contains 106 grams of sodium carbonate. So now we pick up our calculators and we perform this conversion. We basically multiply the 0.948 by 1 over 106. You can also just divide by 106 if that's easier to think about. We get 0.00894, and again, this will be moles of sodium carbonate. So we're going to hold on to that value for a little moment. And in the meantime, we're going to do a similar calculation for water. We're going to say that 1 mole of water is going to equal a certain number of grams of water. Let's look at our periodic table again. And water, of course, contains 2 hydrogens, so we'll do 2 times the mass of hydrogen, which is 1, and then add that to the mass of 1 oxygen atom, which is 16. And when you work this out, you will get 18. So, of course, that means 1 mole of water contains 18 grams. And again, look at the way that we have situated or arranged the conversion. The grams will cancel out. So that's going to leave us with moles of water. So now we just do 1.61 divided by 18, and we get the following. So we have the moles, and now we can figure out the so-called molar ratio. Now, technically, you could write the formula as follows. But if you look at that formula, it's rather unfortunate, let's say, to look at. That's kind of an ugly formula, although it is technically correct. You will remember that the coefficient of the sodium carbonate, this coefficient here, was supposed to be a 1. That's how it started out in the original formula. So to turn it into 1, we would actually divide this coefficient by 0.00894 because any number divided by itself equals 1. But if we divide that coefficient by that number, we must divide the other coefficient by the same number. That way we keep the ratio intact. We keep it a constant ratio. Now, as noted, this becomes a 1. And when you do the other division on your calculator, this division right here, you will get a number very close to 10. In fact, this case, it will be exactly 10 because of the way in which we rounded. So we end up with 10 for the coefficient of water, and that becomes the answer. Because remember, in the original question, they placed an X in front of the water, and we can see here that the X is 10. So that just means that within this compound, there is 10 times as many moles of water relative to the moles of sodium carbonate, if you're looking for that level of understanding. But as far as the answer is concerned, the answer indeed is X was equal to 10.